All right, let's talk about ordering integers. So, for example, saying things like 2 is less than 3, 5 is less than 7. How do we discuss this sort of concept? So, one approach that you can take to discussing this concept is to use a number line. You can place numbers on a number line, and you can say that one number is less than another number whenever the smaller number appears to the left of the bigger number. Okay, so here I can place the numbers -4 and +3 on the number line, and because -4 appears all the way to the left of -3, which appears to the right, then we would say the number that appears further to the right is the bigger number. Right? So 3 is bigger than -4, and this is this you can see very clearly like why positive numbers are always going to be bigger than negative numbers, because positive numbers are always further to the right of the negative numbers. So some students like maybe would get confused as to why -4 would not be the bigger number, because 4 is bigger than 3, but the negative is going to make this number appear further to the left on the number line. So that's sort of why. All right. The addition approach is another approach that you could take. I'll admit this one's a little bit less common, but you can use it, and it's useful in some situations. And so I think it's worth discussing. So we can say that a number A is less than B if there is a positive value of x such that A plus x is equal to B. Right? So if you can find a positive number x that you can add to A to get your other number, then that means that this has to be the bigger number, okay? Because you've added something to the smaller number to get the bigger number. So for example, 2 is less than 5 since 3 is positive and 2 plus 3 is equal to 5. So you can find a positive number that you can add to the smaller number to get the bigger number. And this addition approach will apply to not only just positive numbers, but also to negative numbers as well. So -4 versus -2. Some students might think that, well, -4 is bigger than -2. Like, oh, if you have a debt of $4, that's bigger than a debt of $2, right? So they might think that -4 is the bigger number of the two, but of course it is not. Let me actually make this a -5 so that I don't have too many 2's floating around in the problem. So -5 is going to end up being less than -2, since again 3 is positive and -5 plus 3 is equal to -2. So you can find a positive number to add to your smaller number to get your bigger number. So same sort of thing. And again, this will end up applying to things like, oh, -2 is less than 4. You can use 6 here because -2 plus 6 is equal to 4, and so on. All right. Let's talk about multiplication and inequalities. Let me kind of get rid of that. All right, so multiplication and inequalities. So let's start with the inequality 4 is less than 5. All right, so here I have 4 on the number line, and I guess maybe I'll do this in blue. Blue for the number 5. So here's, okay, color coordinating. All right, so what happens when I take this inequality right here and I multiply both sides of the inequality? Let's say that we're multiplying both sides by 3. So let's multiply both sides by 3. So we would get 4 times 3 is 12, and we would get 5 times 3 is 15. So we already know that 12 is going to be less than 15, I would hope. And so what happens on the number line when we do this, so 4 times 3, we would do this. So 1 times 4, 2 times 4, 3 times 4, we end up at 12. So 12 is over here. And 3 times 5, end up at 15. Okay. All right, so when you do this, it's not going to change like which number is going to be further to the left or further to the right on your number line. So multiplying both sides of an inequality by a positive number does not flip the inequality or anything like that. Like nothing like funky happens or anything. If this is less than that, then that's still going to be true when you multiply them both by positive 3. But when you multiply, or I'm getting ahead of myself. Let's do like negative 3 is less than positive 4, and multiply both sides by positive 2. So here's negative 3, and positive 4 is over here. We're going to multiply both sides by positive 2. 4 times 2 is going to be 8, and negative 3 times 2 is equal to negative 6. And so we're going to end up getting, I forgot to underline, oh well. We're going to end up getting that negative 6 is still less than positive 8. Okay, so got ahead of myself a little bit, but yeah, so this inequality is going to still be preserved when we multiply both sides by positive 2. All right, so what happens when we multiply an inequality by a negative, though? All right, so here we have negative 3 on the left, and we have positive 4 on the right. So we know that negative 3 is going to be less than 4 because negative 3 is further to the left on the number line. 4 is further to the right. And what happens when we multiply by negative 2? Well, 4 times negative 2 is equal to negative 8. And negative 8 on the number line is going to be all the way over here. And negative 3 multiplied by negative 2 is equal to positive 6, and positive 6 appears all the way over here on the number line. And so all of a sudden, this inequality is being flipped. So before, the blue was to the left of the green, but now the blue is going to be to the right of the green. So 6 is going to now be the bigger number than negative 8. So positive 6 is bigger than negative 8. You can see that visually over here. And so whenever you multiply by a negative number, in general, like it will flip the inequality. Okay, so we start with, when you start with an inequality, A is less than B, and then if like n is some negative number, then what you're going to get is that when you multiply n times a versus n times b, instead of b and b being bigger, it's going to flip the inequality, and so na is going to be bigger. Okay. All right, so multiplying by a negative flips your inequality, and you can, again, just view the number line in a variety of situations to kind of convince yourself or your students or whoever about this.